let's look at an example for writing formulas for ionic compound that uses the stock system. The stock system comes into play because some ions can have different charges. For instance, most transition metals can have multiple different charges, and the transition metals are here, the dip in your periodic table. Most transition metals can have more than one charge. For instance, iron can have a charge of +2 or +3. Copper can have a charge of +1 or +2. And so the expectation is that for transition metals, they can have more than one possible ion. The exceptions to this rule are tin and cadmium, which both form ions with a charge of +2. And that's the only ion that those elements form. The other notable exceptions are two elements that are not in the transition metals, tin and lead. Now, according to the rules for ion charges, we would expect these ions to form, these elements to form ions with a charge of ±4, but in reality, they form ions with a charge of +4 or +2. +4 or +2. So tin and lead can also form ions with different charges. So we need a way of naming those compounds that lets us know which ion are we talking about. Are we talking about the +2 or the +4? So let's look at how to do these examples. And let's use lead as our example. As I've already mentioned, lead comes in two versions. Lead comes as an ion with a +2 charge or as a +4 charge. So if we talk about lead oxide, there are two different versions of lead oxide. We could have lead 2 oxide and lead 4 oxide. Notice those Roman numerals written in parentheses next to the lead name. Compounds that can have different that have ions that can have different charges are named by including the charge on the ion next to the name in Roman numerals using parentheses. So, if we have lead 2 oxide, let's do that as our first example, lead 2 oxide, we're talking about lead ions that have a charge of +2, and we're talking about oxide ions that have a charge of -2. So how many lead and oxygen ions do we need to balance each other out? Remember, positive and negative charges must cancel out so that the total charge is 0. Well, if I take one lead ion and one oxide ion and put them together, that's it. I'm done. Those charges exactly cancel each other out. So the formula for lead 2 oxide is just PbO. 1 lead, 1 oxygen. The charges balance each other out. If we contrast that with lead 4 oxide, this time we can still use these red Legos to represent our oxygen, but this time I need a different size Lego to represent my lead. I'm going to use these yellow Legos that have 4 circles on top to represent lead. So how many of each kind of ion do I need now? If I have one lead ion with a charge of +4, with one oxide ion with a charge of -2, they don't exactly cancel out. I need more negative charges here to balance out my positive charge. If I add one more oxide ion, my charges are balanced. My positive charges are exactly canceled by my negative charges. In this case, I only needed one lead ion, but I needed 2 oxide ions. So my formula is PbO2. Notice that the difference here doesn't come really in how we write the formula. The difference comes in the name. And the name is important because the name tells us the charge on the ion when the ion can have more than one charge.